Before we get started with lesson 3, there's just something I want to make sure we go over quick. It's a combination of coordinate graphing and similarity. So I want to make sure we go over it because it's something that pops up a good amount of times. The line 2x plus y equals 6 is dilated by a scale factor of 1/3 centered at the origin. What is the equation of the new line? So here's the key. When it's centered at the origin, the first thing you want to do is you want to take your line and you want to make it equal to 0. So y equals negative 2x plus 6. Sorry, not equal to 0, equal to y. Okay. So now we know that dilated lines, and we had our two P words from a couple units ago, they were parallel and proportional. Okay. Now, if it's parallel, we know that that means they have the same slope. So therefore, we know the equation of our new line is going to be y equals negative 2x because our slope has to stay the same. And now the only thing you're going to do is you're going to multiply the y-intercept only. Okay, so if you do 6 times 1/3, you get 2. So then our new y-intercept is 2. So the equation of our line would be y equals negative 2x plus 2. Okay, so again, if you are dilating a line centered at the origin, you're going to keep your slope the same and multiply your y-intercept by your scale factor. Now, the other way that these questions appear is, that's not a negative, it's just a dash. 2x plus 3y equals 8 is dilated by a scale factor of 2 centered at the point 1, 2. What is the equation of the new line? Now, whenever they're centering it at a specific point, the first thing you want to do is you want to check to see if it is if it is on the line. So 2 times 1 plus 3 times 2 equals 8. 2 times 1 is 2, 3 times 2 is 6, and you get 8 equals 8. So what that means is this point is on the line. All right, and when you dilate a line centered at a point on the line, your equation stays the same. Okay, so now if that point wasn't on the line, in all honesty, the only thing we could do is actually take out some scrap graph paper and probably use our compass, but that pretty much never shows up. The only two options usually are centered at the origin or centered at a point that is on the line. So in this case, we want to make sure we answer the question, what is the equation of the new line? It's the same exact thing. It's still 2x plus 3y equals 8. All right. So make sure you understand the difference between when you center a line at the origin and when you center a line at a point that is on the line. So now as we head into lesson 3, dividing segments proportionally, we're going to talk about taking line segments that are on a graph, and we're going to divide them sometimes in half, but sometimes by different measurements as well. On the axes below, graph the segment AB with endpoints 1, 2, and B, 7, negative 2. So everybody take a second, graph those points. So 1, 2, there's A, and then 1, 2, 3, 4, 5, 6, 7. Negative 2, there is B, and I want to make sure that we connect them. So we're going to connect them with a segment. Now again, it's a segment, not a line. All right. Using your knowledge of coordinate geometry, find the midpoint. Okay. Now, to me, the easiest way to do this is almost to make this into like a right triangle, basically by finding our slope. So if we go from A to B, we have to go down 1, 2, 3, 4, so negative 4, and then over 1, 2, 3, 4, 5, 6. So now if we want to determine our midpoint, we're going to do half of negative 4, which is negative 2, and we're going to do half of 6, which is 3. So now I'm going to go down 2 and over 3, and that will get me to my midpoint. We'll call it M, and that has the coordinates 1, 2, 3, 4, 0. All right. So if it wants us to explain how we arrived at that answer, we could just say we found the slope and divided both numerator and denominator by 2, okay, or multiplied by half, kind of up to you. All right, but that's the graphic way to do it. Is basically find the slope and then cut that slope in half. The algebraic way to do it is as follows. Now this should say, I don't know, this should say 4, sorry, not 3. But basically what you are doing is you are finding the average of the x's and the average of the y's. All right, so you can see the x part of the midpoint is 1/2 of 7 plus 1. So you're adding your two x values together, half 8 gives you 4. And then for the y midpoint, you're adding your y's together and then dividing by 2. So you're basically just finding the average of your x's and your y's. So let's find the midpoint of segment CD with the endpoints C 810 and D -12.6. So if we want to find the x part of our midpoint, it's going to be half of 8 plus -12. Well, that gives us half of 8 plus -12 is -4, and half of -4 is -2. Then for our y midpoint, will be half of 10 plus 16. So that gives us half of 26, and half of 26 is 13. So therefore, our midpoint would be -2, 13. And on the bottom, we'll do the same thing. Our x midpoint is half of -3 plus 11. -3 plus 11 is 8, and half of 8 is 4. And then for our y midpoint, we would be half of 5 plus -14. That would give us half of -9. And you could leave it as 4.5. You could leave it as preferably not 4.5. I don't like mixed numbers. You could leave it as -9/2. But since this is going to work out nicely, I'll just make it into a decimal. So our midpoint there would be 4, -4.5. So in some of these now, when it's not the midpoint, we have to do a little bit of extra kind of work and thinking, and we want to make sure that we are setting ourselves up to work with these problems a little bit differently. So example 2 says point Q is on segment MN. So it's that MQ to QN is in a ratio of 2 to 3. So because our ratio is not basically 1 to 1 or a half like our midpoint is, we have to work with these a little bit different. If M has the coordinates 0, 3, and N has the coordinates 5, now this is supposed to be 5, -7, and that'll help us a little bit. We want to determine the coordinates of Q. So the first thing we want to do is we want to graph them. So there's M, 0, 3, and then 1, 2, 3, 4, 5, and there's N, -7, all right? And we're going to connect them with a segment. So the easiest way to do this is still to do it graphically. And just like we do with our midpoint, the first thing we want to do is we want to count our slope. So we have to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're down 10, and we're over 5. Now, when we addressed our midpoint piece there, if we look back at the opening exercise, we multiplied both of those numbers by a half. But it's a little bit different here as we deal with our ratio. So here's the rule for the ratio. It's always the first number over the sum. So in this case, the first number is 2, And then our sum is 2 plus 3, and that gives us a fraction of 2/5. Okay, so that's the fraction we're going to be working with here. So it's the first number over the two numbers added together. So if we look at our -10 and we multiply that by 2/5, that gives us a new slope of -4. And then if we look at our 5 and multiply it by 2/5, that gives us a new slope of 2. So now we're going down 4 and we're going right 2. So 1, 2, 3, 4. So there's our down 4 and our right 2. There's point Q, which has the coordinates of 2, -1. All right. So basically what we're doing when we graph it is we're just tweaking the way we did our midpoint. And realistically, the only thing we're changing is instead of multiplying it by a half, we just have to do some quick math with our ratio to figure out what our fraction is actually going to be. Now, just like with this midpoint, there's an algebraic way to do it. So it says xq equals 0 plus 2/5 times 5 minus 0, and that gave us the coordinate of 2. And then yq was 3 plus 2/5 times -7 minus 3. Okay, so here is basically what the formula looks like. And I'll use xq just to stay consistent. So it's x1. Now the key is with x1, it's always the point that's furthest to the left. Usually with these problems, they list the points from furthest to the left to furthest to the right anyway. So usually it's the first point plus whatever your ratio is, and then times x2 minus x1. And then yq is the same thing. It's y1, which again is the one on the left, plus whatever your ratio is, times y2 minus y1. Okay, so the 2/5 was our ratio that we worked with. And then you just basically subtract the points, essentially like you're finding the slope. The x2 minus x1 and the y2 minus y1 should look familiar from finding our slope. So if we look at example 3, we want to determine the coordinates of the endpoints of AB are A, -8, -4, and B, 6, 4. Point P is on AB. Determine the coordinates of P such that AP to PB is 3 to 5. So again, I know it's the first number over the two numbers added together. So I know it's 3 over 8 because 3 plus 5 is 8. I want to try to use the formula that we just came up with. So if we want to find our XP part, it's always our x1 plus our ratio times x2 minus x1. So if we look at these 2 points, which one's furthest to the left? Well, obviously it's the -8, -4. So then we are x1, y1, x2, y2. So -8 plus our ratio is 3 over 8. And then x2 minus x1 is 16 minus -8. So we know minus minus really turns to plus. We get -8 plus 3 over 8 times 24. -8 plus, if we do 3/8 of 24, we get 9. And then -8 plus 9 is 1. So there's the x part of our p coordinate. So now we're going to do the same thing for y. So it's the same formula, just every place we had an x, we're going to replace it with a y. So our y1 is -4. Our ratio is still 3 over 8. And then we are 4 minus -4. All right, so plus plus again. -4 plus 3 over 8 times 8. 3/8 times 8 is 3, and -4 plus 3 is -1. So our yp is -1. So what's the coordinates of p then? Well, the x part is 1, the y part is -1. So therefore we get a 1, -1 answer. If you had scrap graph paper, of course, you could always just put it on there, graph your 2 points, and go from there. But I want to make sure I show it to you algebraically in case it shows up in a question that doesn't have graph paper. Same thing in example 4. Point P is on segment AB, such that AP to PB is 4 to 5. So we know right away 4 over 9 is going to be our important piece. If A has the coordinates of 7, 2, and B has the coordinates of 25, 2, determine and state the coordinates of P. So again, identify the one that's on the left, x1, y1, and then x2, y2. Now it seems a little bizarre that both y values are 2, so that might be something that we need to pay attention to. But let's go with our formula here. So it says x1, so 7, plus our ratio is 4 over 9, times x2 minus x1, so 25 minus 7. 7 plus 4 ninths. 25 minus 7 gives us 18. 4 ninths times 18 gives us 8. And then 7 plus 8 is 15. So there is our x value for P. Now as we go to our y value, so y1, which is 2, plus our ratio is 4 over 9. y2 minus y1 is 2 minus 2. So interesting here as we go about this, we get 2 minus 2 is 0. So we get 2 plus 0, which gives us 2. So our yp value is 2. So that gives us our actual p value to be 15, 2. So what hopefully you'll notice is whenever if you have an x value that's the same for both points, or a y value that is the same for both points, you really don't have to calculate your divided proportionally point or whatever you want to call it. You really don't have to do the formula for that piece if y1 and y2 are exactly the same, because you know that means that point's not going to change and you're going to end up in the same exact spot. So you'll just have to do it for the other value. So the key for this is get to know how to do it by slopes, but then you also want to make sure that you put these two formulas in the back of your head in case it is not a graphing problem.